Good evening to all. Today, I would like to share electronics model paper number 2. Prior to this, I have already shared electronic model paper number 1. I have shared enough videos with regard to communication procedure examination model papers for ham radio. I am sharing this model paper with a view to help those people who wanted to appear for ham radio examination. They wanted to prepare for this examination to crack restricted, and also it will be useful to crack general grade also. Now this is model paper number 2, section A. Normally section A will be electronics and section B communication procedure. So the first question, and this is the color bands of a 4.7 kilo ohms plus or minus 5% resistors are. You have to choose a correct option from these following options. Now to find out the correct option, 4 is yellow. 4 is yellow. And 7 is violet. You can convert this 4.7 kilo ohms 4700 ohms. You need 2 zeros. To get 2 zeros, you can put the third color, that is multiplier, red color, and 5% is gold. So the answer is yellow, violet, red, gold. Yellow, violet, red and gold. Bravo is the correct option. Second question, a signal FM is amplitude modulated. FM is frequency, amplitude modulated frequency. And the similar manner, FC is equal to carrier frequency. FM is a modulated frequency. And we have to find out the frequency value of lower sideband. See, normally carrier frequency will be high and modulated frequency will be low. So, lower sideband frequency, it will be like this. FC minus FM, that is carrier frequency minus modulated frequency. To find out similarly upper sideband, it becomes like FC plus FM. So answer is FC minus FM, that is Charlie is the correct option. The doping concentrations of emitter, base and collector in a NPN transistor is, so normally the emitter will be heavily doped to supply sufficient amount of charge current. So heavy. So base is light. So there should not be any current flow through the base. So base is very light. And collector is moderate. So heavy, light and moderate. Heavy, light and moderate. Here this is the option. Bravo is the correct option. The wavelength of a signal Vt is equal to 5 cos 6 pi 10 power 6 t is. We have to find out the correct option. Here the correct answer is 100 meters. The wavelength of a signal Vt in this, through this we will get this 100 meter. And we'll find out how we have got this answer. Here the sum is like this. The wavelength of a signal, this is the sum. Here a formula Vt is equal to A cos omega t plus pi. Vt means voltage depending upon time scale. So here cos omega t plus pi is deemed to be 0. So here omega is equal to 6 pi 10 to the power of 6. So 6 pi 10 to the power of 6 radians per seconds. We have to convert this angular frequency into regular frequency, normal frequency. You have to divide it by 2 pi. F is equal to the normal frequency omega by 2 pi. Omega already we know from this formula, that is 6 pi 10 power of 60. 6 pi 10 power of 6 by 2 pi. Here this 2 pi cancels into the 6 pi. You will get 3. 3 into 10 to the power of 6 cycles. Now we know the formula. C is equal to light speed is equal to frequency into lambda. So we will get from this formula, lambda is equal to C, that is light speed by frequency in hertz. So we already know this is the light speed is a fixed. C is equal to 10 to the power of 8 meters per second. So lambda is equal to C by F. C we already knows this one, 3 into 10 to the power of 8. And F we have calculated as F is 3 into 10 to the power of 6 hertz. F is equal to. So we will get from this formula 10 by 8 by 10 by 6, it becomes 10 square is equal to 100 meter. The final answer is 100 meter. The mutual inductance M between two coils of self-inductance L1 and L2 respectively can be expressed. A formula for this is M is equal to mutual inductance. It is a constant coefficient into root of L1 into L2, the inductance of first coil and inductance of second coil. So Charlie is the right option. So next, question number 6. For a step down transformer, the relation between the number of turns in primary, that is NP, and the number of turns in secondary. Since it is a step down transformer, the secondary turns will be less than that of primary turns. That is NS lesser than NP. So Bravo is the correct option. The layer that reflects higher end frequencies in HF range during the daytime is F2 layer. Answer is correct answer is F2 layer. The layers will be spread like this. The topmost will be F2 and beneath this is F1 and the next layer is E layer. Next layer is D layer, that is very near to the earth. This is the earth. So higher end frequencies that will be reflected by this layer, that is F2 layer. Correct option is F2 layer. The power conversion efficiency of a full wave rectifier is 81.2%. The length of dipole, reflector and director of a antenna in terms of wavelength are dipole, that is the value it will be in the mid size. So here the mid size is 0.5 lambda. So 0.5 lambda. And reflector will be big wavelength. Reflector big wavelength, it will be 0.55 lambda. 0.55 lambda. And the last one, director is the smallest element for wavelength, in terms of wavelength. So that is 0.45. 0.45. So it should be like this, in this order: 0.5, 0.55, 0.45. So Charlie is the option. Charlie is the correct option. The sideband system adapted for television transmission is vestigial sideband. Vestigial means remaining part. Like the appendicitis in our body is a vestigial part. Bravo is the correct option. One of the limitations of usage of BJT, bipolar junction transistor, at micro frequencies is, it is size is a problem, power is problem, transit time. So these are all limitations. All the above is the correct option. The oscillator that makes a communication receiver capable of receiving Morse code, that is beat frequency oscillator. Normally, we can convert ordinary radio into a communication receiver. IF frequency in a radio receiver is 455. So beat frequency should operate plus or minus intermediate frequency. Suppose IF is 455. Yeah, it should BFO should operate on 2 kilocycle upward or downward. So we can take it as 457 kilohertz. So 457 minus 455, the difference is 2 kilohertz, which will be in the audible range. So beat frequency oscillator is the correct option here. The circuit enables the radio receiver output to remains cut off when carrier is absent. That is squelch circuit. This circuit is will notice in the VHF communication networks. It is very, very useful. Whenever a signal is coming, then only receiver will be open. Other times it will be in the cutoff position so as to not to make any noise and disturbance. So the category of a pulse modulation that comes under digital system is pulse code modulation is correct, pulse amplitude modulation is correct, pulse time modulation is correct. So all the above is the right option. All the above is the right option. The highest frequency that is reflected by an ionosphere layer is critical frequency, because when the signal is transmitted upward vertically at some frequency, it will come back, and if it is behind that frequency, it will penetrate. The maximum usable frequency is something different to communicate a particular point. So this is useful. So if you cross this maximal frequency, so even though electromagnetic wave coming to the earth, it is behind our usable frequency. So if you are communicate to A to B, if you increase the frequency, so what happens? You may not be able to communicate this B point. So maximum usable frequency, you have to understand that way. Here in this case, the answer is critical frequency. 16. The device that can be used as voltage regulator is a Zener diode. The reactance of a capacitor increases when the frequency is decreases because it is in the opposite direction. Excess C is equal to, that is capacitive reactance, 1 by 2 pi Fc. Here if the frequency increases, capacitive reactance will decrease. So here in this case, if frequency decreases, capacitive reactance increase. So the reactance of a capacitor increases. It should increase. So the frequency should decrease. Bravo is the correct option. The elements in the tank circuit of Colpitts are L and C, inductance and capacitance. The circuit that reduces ripples from the output of a rectifier is a filter. Express the gain of an amplifier in dB when the output power of its 100 milliwatts to the input of 10 milliwatt. Answer is 10 dB. To know how we have got this answer, please kindly observe this one. Express the gain of an amplifier. Okay, to express the gain of an amplifier, here it is a formula. Gain dB 10 log P out by P in to the base 10. Here we already know P out is 100, P in is 10 from the formula. So we have to see P out is 100 and P in is 10. Simply you have to substitute these values. 10 log 100 by 10, 100 by 10, that is the P out by P in is equal to 10 log 10 to the base 10. Here in this case 100 by 10 becomes 100 by 10 becomes 10. 10 the log to the base 10. We know this, it will becomes 1. 10 into 1, 10 dB. So correct answer is a 10 dB. Similar manner, the output of an amplifier with a 10 dB gain and an input of 1 milliwatt. So output an amplifier, it was given a 10 dB and the input is 1 milliwatt. Here is also using the same formula we can solve this. So answer is 10 milliwatt. How we have got this answer? Just follow this one. See, we use the power gain formula in dB, 10 into log P out by P in to the base 10. So gain is 10 dB. So P in is 1 milliwatt. Rewriting this, substituting these values, 10 is equal to, that is gain, 10 into log P out by P out by P in, that is 1. P out we don't know, we have to solve. Here in this case it becomes log P out by to the base 10 is equal to 1. See here 10 cancels, it becomes 1 is equal to log P out by P out by 1, that becomes P out. P out by 1 means P. So log 10 log P out by P out to the base 10 is equal to 1. So here it becomes when it will becomes 1 log 10 to the base 10. So naturally this P out becomes 10 to the power of 1, that is 10. Correct option answer is 10 milliwatts. The transformer are rated in volt amperes. Batteries are connected in parallel to get more current capacity. Super heterodyne receiver with a local oscillator frequency range 3.455 to 30.455 megahertz is capable of receiving the input signal range is 3 to 30 megahertz. The 455 is the IF frequency. You have to local oscillator minus IF that becomes the signal frequency. So here in this case, after substituting of these values, 3.455 minus 455, that is 3. 30.455 minus 455. 455 is the intermediate frequency. Universally IF frequency is 455. So 3 to 30 megahertz. The capability of a receiver to receive weakest possible signal is sensitivity. Sensitivity is the ability of a receiver to respond to a weak signal. So, all the 25 questions are completed. You need to get, you should be able to write at least 10 questions. 10 questions means you will get 10 into 2, 20 marks. That is the qualifying mark. So out of 50, if you get 20, that is a qualifying marks for electronics. Easily one can qualify. Now itself, those who are having some electronic knowledge, they can easily get this. Very easily, they can crack general grade also. General grade in the similar questions, more or less. So questions will be numbering 50. So with this, I would like to say 73s. Hopefully, this is going to helpful to you to crack restricted and as well as general grade. If you want any advices, if you want Morse code training, a special dedicated Morse code training, you can contact me through my telephone number 92483 46843. With this, I say 73s. Bye bye. We'll meet again with some other topic. Bye 73s. Bye.